Hello, peoples. It's Emmett. I'm here, and I had one doing a class about ionic bonding, but something happened to it. I don't know what. So I'm just going to go on to covalent bonding. If I have time, I'll do another one. So, covalent bonding of atoms. So, what is covalent bonding and who, the what? So, generally, covalent bonding is with nonmetals, but for our purposes...
Is it recording?
Yes, it's recording. That's why I'm talking. That was 9. Again, take marks off of her grade or whatever. And so it generally happens with nonmetals, but for our purposes, we're just going to use whatever. But most of the time, it will be nonmetals in our examples as well. I'm just saying. Disclaimer. So, covalent ionic bonding is when they basically trade off electrons. But covalent bonding is when they share electrons. So in our first example, we're going to take carbon and hydrogen. So, carbon, if you'll check, can bond with 4 atoms. And hydrogen can only bond with 1. So, in order to fulfill carbon's needs, so to speak, you're going to need 4 hydrogen atoms. So basically, these are just imagine it as they're branches off from carbon, like open slots. And each hydrogen has 1 slot that can connect to 1 carbon slot. What it'll look like is this. Because each one of their slots, as you can see, because I changed the color to make it blend, is connected to another one. So that's basically they're sharing it, and what it'll look like is sort of clouded together, overlapping. But so anyway, it gets a little more complicated than that. Because there are multiple bonding. You can have, instead of just 1 line connecting 2, you can have 2 or 3, potentially 4, but there aren't really any 4 in nature. So, for this example, we're going to use beryllium, which has a bonding number of 2, which is not how it would be expressed like this, but I just put it there for convenient purposes. Boron, which is 3, and hydrogen, which is 1. So, how this would look is since beryllium has 2, it would connect with boron with 2. It will get rid of both of them. Will not get rid, but share both of them. And beryllium has 3, but 2 of them are being shared with beryllium, which would mean it only has 1 left. And hydrogen only has 1 to begin with. So they share. So boron has 1 and hydrogen has 1 left. And they would share those. And it all works out. You see? And ionic bonding, mine was deleted. So I guess I can start another one if I have time. Yeah. So ionic bonding is basically when they share. And it works like... So let's say... in order to make an atom stable, is its official term. So we all know atoms have shells. And to make an atom stable, you want all their shells to be filled. For example, hydrogen has 1 shell because it only has 1 electron. And that shell holds 2. The next shell would hold 8, but let's not worry about that yet. So the rule is, because there are very few that only have 1 shell, but if it has 1 shell, like hydrogen, you round down, and you want to get rid of this 1 electron. So, you have to find another atom. Let's do fluorine. Fluorine has 2 in its inner shell, and then the outer shell holds 8, but it only has 7. So, hydrogen wants to get rid of this 1 atom by giving it to another element. And this element needs one more electron to make its shell whole, which would make it stable, so it wants that. So hydrogen will give this atom to fluorine, making the shell whole. So this would make them whole, but for example, hydrogen, because it has less electrons, so it's simpler. Hydrogen had one proton in the center and one electron, so they balance each other out. But now it just has one proton, which means it is overall positive. On the other hand, fluorine, whatever, I don't know how to say words. Fluorine had 9 protons and 9 electrons. And now it has 10 electrons, which means it has one more electron than protons, which means overall it is negative. So since fluorine is negative, don't mind that, that's just all the people coming in, and hydrogen is positive, they, since opposite charges attract, would be attracted to each other.
They share their electrons?
Yes. That's correct.
Are you doing ionic?
Yeah.
Oh, okay, I'm sorry.
So since they're attracted,
They give
basically
to one another.
just enough.
I'm sorry.
They would just basically come together in one holy matrimony. And this is kind of rushed, so I might not have delivered it as well as I could. But yes, that's the end. Goodbye.
6 minutes.